Hello and welcome to today's lesson. My name is Lawrence Mwansa. Today we shall look at vectors. At the end of the lesson, I expect you to distinguish between a scalar quantity and a vector quantity. Secondly, I would expect you to give some examples of scalar quantities and examples of vector quantities. Thirdly, when I give a line segment as a vector, you would be expected to write that vector in component form. And when you are given a vector in component form, I would expect you to draw a line representing that vector given in component form. Let us now go into the details of our program. Our lesson today will talk about vectors. Let us define what a vector is. There are some quantities that we deal with which only have to do with a numerical value, and there is no direction given to such a quantity. Such quantities are known as scalars. So we have scalar quantities. A scalar quantity is a quantity that has just magnitude only, without direction. Some examples of scalar quantities are distance. When you travel a certain distance, you say, I covered 50 kilometers. The quantity there is 50 kilometers, which is the magnitude. Then the unit is kilometers. So a scalar quantity is just a numerical value with a unit attached to it. For example, you can have 60 degrees Celsius. The magnitude is 60. The unit degrees Celsius. Or you can have 200 kwacha. Just the magnitude 200. The unit kwacha. Or you can have volume. Say the volume of a certain vessel is 300 cubic centimeters. Those are examples of scalar quantities. So scalar quantities include things like distance as examples of scalar quantities. We have distance. When you are measuring something, you can give the length of an item. As we said earlier, you can talk about the volume. It will just give you a numerical value with a unit attached to it. Thirdly, you can have area or even temperature. All these are examples of scalar quantities. Remember how we have defined scalar quantities? It is a quantity that has only magnitude without any direction, or it is just a number with a unit attached to it. The opposite of scalar quantities is what we are talking about today, vectors. What is a vector quantity? So vector quantities vector quantity is just the opposite of the scalar quantity. A vector quantity has magnitude also, but it also has direction. So a vector quantity is a quantity that has both magnitude and direction. When you're talking about displacement, remember in your physics lesson, your teacher would have said a vector quantity has both magnitude and direction. Meaning, if you're talking about displacement, it is the distance covered in a specified direction. So when you have a quantity representing the magnitude and then the direction attached to it, that quantity becomes a vector quantity. Let us state some examples of vector quantities. One, as I mentioned earlier, displacement. Displacement is distance covered in a specified direction. Distance covered in a specified direction. So the direction itself qualifies this to be a vector quantity. What else? We have velocity. Velocity, as you learned in your physics lesson, is the rate of change of displacement with time. So there is direction also involved in velocity. So velocity is an example of a vector quantity. Then we have force. When you are applying a force to any object, the force is applied at a certain angle, or you can put it in a certain direction. So force is also applied in a given direction. So force is another example of a vector quantity. The fourth one we can talk of is acceleration, which is the rate of change of velocity with time. So acceleration is also an example of a vector quantity. Talk of weight. The weight of something, it will be a vector quantity. You might wonder, because we just give the weight in kilograms. Weight, as you know, differs from mass. Mass is the quantity of matter contained in an object. But with weight, the direction is the pull of gravity towards the center of the earth. So when you're talking about weight, there is direction involved. So weight is an example of a vector quantity. Yes, it will give you the magnitude, 50 kilograms, but it is pulled towards the center of the earth. So that gives us the qualification that weight is a vector quantity. There are so many examples we can give on. Let us end there just as our few examples. I'll just say ETC. Fine. We have looked at the distinction between scalar quantities and vector quantities. Next, we shall now concentrate on our vectors. How do we define vectors mathematically? We shall have the following definitions also added. And now going to our mathematical perspective. How shall we define a vector? A vector is also defined as a directed line segment. So we shall say a vector is a directed line segment. What do we mean? It is just a line with direction. So this directed line segment simply means it is a line. It is a line with direction. So in our topic, when you see a diagram, a line given direction, that will show that it is a vector. We mean this. If I have this line AB, the way it is not a vector. It is just a line. But immediately I show the movement of direction. And the movement of direction will be shown by an arrow. So I'll put an arrow to show that I'm moving from A to B. Now it becomes a vector. It is not just a mere line. The arrow is now showing me that I am moving from A to B and not the other way around. So the arrow gives me the direction. So we say a vector is a directed line segment. A line and the arrow shows the direction. I can have another vector. I can move from P to Q. I can say the vector PQ. We are moving from P to Q. Another definition we shall be using in mathematics is the following. We shall say a vector is a column matrix. A vector is a column matrix. You have done matrices as a topic. When we say a column matrix, this is just a matrix which has one column. So we can have a vector like this one. I'll say vector AB equal to 2, 3. This vector is now written as a column matrix. You can see this is a 2 by 1 matrix, only one column. So vectors will usually be represented as column matrix. I can have another vector A written as -1, 5. This is another vector. Vectors written in this way with only two numbers are called vectors in 2 dimensions. So we can increase the number of numbers in that vector. So this one is in 2 dimensions. If I put another number in the vector, I can say vector PQ, which is equal to maybe 3, -1, 4. This vector is in 3 dimensions. So a vector in 3 dimensions. Is it a column matrix as well? Yes. We only have one column. This is a 3 by 1 matrix. So it is also a vector. Our topic will only concentrate on 2-dimensional vectors. We will not look at the 3-dimensional vectors. You meet them later as you climb the education ladder. So our main task will be on 2-dimensional vectors. In these vectors we have written, there are these numbers. Vector AB, we wrote it as 2, 3. These two numbers written have a special name. We call them components of a vector. So in the vector AB, which we wrote as 2, 3, the numbers 2 and 3 are called components of vector AB. The numbers 2 and 3 are called components of a vector. Components of vector AB. The components of vector PQ are 3, -1, and 4. But the components of vector A are -1 and 5. So the components of vector A are -1 and 5. In the other one, the 3-dimensional vector, the components of vector PQ are 3, -1, and 4. Those are called components of a vector. When you pick up a mathematics textbook, you start reading. How do you know that what I'm reading is about vectors? How are vectors written? So let us look at what I will call vector notation. Vector notation. Vectors are written using capital letters with an arrow on top. That is, we wrote vector AB and vector PQ. Always use a capital letter with an arrow on top. So I'll write here, vectors are written using capital letters. They are written using capital letters with an arrow on top. The arrow shows the direction of movement with an arrow on top. Okay, the examples we already looked at, we had vector AB. We write AB. How do we show the direction? The arrow should move in that direction, showing you that the movement is from point A to point B. So the arrow gives the direction of movement. If the movement is from B to A, we write this as follows. If the movement is from B to A, is from point B to point A, we write this as I'll write this as BA, then the arrow on top. Please do not write this and not as, don't write this with the arrow facing backwards. We don't write vectors like that. So when you are writing a vector, do not write the arrow moving backwards. The arrow is always written pointing to the right. So even if you are moving from B to A, we'll start with the letter B, and then the end point is A. So the movement will be from B to A. So take note, the arrow is always written pointing to the right and not backwards. We have said vectors are written using capital letters. There are times when you see a vector written using a small letter. If a small letter is used to represent a vector, then the small letter must be underlined. In some textbooks, they won't show the arrow, but they'll print it in bold. So when you are reading about the topic vectors and you don't see these arrows, the print, sometimes they will print to show that it's a vector by printing the AB in bold type, just to differentiate from the ordinary letters AB. But the AB will be printed in bold. Yeah, most textbooks, they will always show an arrow on top. But do not be surprised. You're talking about vectors, then you don't see the arrow. But the difference there will be the AB will be printed in bold type. As I said, if we use a small letter, if a small letter is used to represent a vector, then the small letter must be underlined. If a small letter is used to represent a vector, then the small letter must be underlined. It must be underlined. And this is a must. If a small letter is used to represent a vector, then the small letter must be underlined. By small letter, I don't just mean you make the capital letter look small. No. By small letter, we mean the lowercase letters, the opposite of capital letter. So if I write vector A equal to -1, 5, vector A is underlined. Why? This is to differentiate just the ordinary letter A, or the algebraic letter A, to differentiate it from the vector A. The vector A is underlined. So the same in print media, when they do not underline the letter, they will print it in bold type. So again, do not be surprised when you see they are saying this is vector A. It is not underlined, but they'll always print it in bold type. In handwritten, you must always underline it to show that it is a vector. I can have another vector V underlined and say this is equal to -3, -4. Again, that is a vector using a small letter V. There are so many that you can write. Vector P equal to, let's say, -5, 9. That is another vector P. The P, you can see it is small and it is underlined. As we mentioned earlier, the numbers that are in the vector are called components of a vector. Now, let us see the parts of a vector. We say the vector is a directed line segment. Parts of a vector. When I have a directed line segment, and then I say this is vector A, I'll write it like that. Now, the starting point of the vector, the point where the vector starts from, is known as the tail of the vector. And the end point is known as the nose. So a vector has a tail and a nose. So the starting point here is the tail. The end point, the nose. So every vector has a starting point and an end point. Every starting point is called a tail, the end point, a nose. Even if I have a vector PQ, the point where it is starting from is what is the tail. The end point will be the nose. So this, we use it in vector addition, as we shall see later. When you are adding vectors, the way it is, if I want to add vector AB plus vector PQ, then we add tail to nose. We shall see that later when we come to vector addition. Vectors in component form. A vector written in component form is usually just known as a column vector. When you write a vector in component form, the way we wrote vector V, this form of a vector is known as just a column vector. So we'll say a vector written in component form. A vector written in component form is called a column vector. Is called just a column vector. And this term is what we'll be using mostly, even when you are solving question. The question will say, express this vector as a column vector. I mean, you write it in component form, where you write the two components. A column vector describes the movement of an object in both the x direction and the y direction. The column vector describes the movement of an object in both the x direction